This time I have a BGW750. This is a power amplifier that could put out up to 750 watts in mono mode, about 230 I believe in stereo mode into 8 ohms. These were used by movie theaters a lot back in the earthquake movie days. They were used to shake the seats and so forth. This one's got no sound from the left channel. Let's check it out. BGW750, one channel dead. Right channel works. Left channel, nothing. This is a dual mono design, so there's two separate amplifier boards on this unit, one for the right channel, one for the left channel. Well, we already know where the problem is, right? The problem on the left channel. That's where the problem is. Okay, I get the top off it, and the left channel started to put some sound out. Momentarily it did. Haven't done any tests yet, but we heard some sound out of that left speaker. And then it cut out. I wonder if it's a relay. Speaker relay, maybe? We got some sound, so that means it's not blowed up completely. Let's just see what type of volts we have here. Minus 78 and plus 78. Same as on this side here. Plus 78 and neg 78. So we got power. Between our collectors, we have 157 volts. So this is a good one to give you a good jolt. You want to keep your fingers out of this one, right? A high voltage amplifier, very dangerous. Put your fingers across those collectors and you're going to feel it. Let's put it that way. You're going to feel it. Once the power is cut off, probably take a bit for these to drain down. A few minutes, you know, it goes pretty quick. We're down to 38 volts now. They will drain down relatively quick. So when the power is not applied, you're not really in for much of a risk on these because the caps won't hold a charge. They will self-discharge. Probably have discharge resistors on them. We gotta figure out though why we've only got sound on one channel. And let's say the sound did come on this channel. I'll just turn it on again. I did have sound. I did have sound. Right channel. Left channel. That's got nothing. But I did hear sound there momentarily. So let's just pull the amp board and see why we're not getting sound. Is it something on the input? Here's the amplifier board here. This is one I changed the fan on a while back. Put a little DC fan in here because the fans that came with these things were just so annoyingly noisy. So the fan was changed out for a computer type fan years ago. I did that work. Here's the board itself. Kind of want to power this thing up. All right, put some bubble wrap in there. Let's power it up. Now we are live. Here's our audio go in on this. It goes in down here. Yeah, I'm going to clip my scope to the input. Amplifier is not turned on at the moment. Let's take a look at the scope. See if I got any input when I turn up the volume. I should have. Silly scope shows I have input when I crank up the volume. And I got no sound coming out through the speaker because it's got power. So we got power going in. Where are we losing the signal? This time we're going to look at the bass drive. This is the common bass drive that drives all the outputs on here. This will tell us if I've got signal here. This will tell me that the op amp is working and I'm getting power going to the output. So let's power it up again and take a look on the scope and see if we have any signal here. Moment of truth. Volume is turned down. Power on. Bring up the volume. And as you can see, we have power getting to the output transistors. So now let's look at the output from the output transistors and see if we get any power there. I believe that's the speaker output. I'm pretty sure that's the speaker output. Let's turn it on and see if we get any signal. That would tell me that the amplifier itself is working. And I think this amplifier is working. I think our problem is after this, but before the speakers, before the speaker connection. So in other words, it could be a connection on the back. It could be the relay that cuts off power for speaker protection, for example. Yeah, that could be. It could be the relay. It could be the relay. It could be a bad connection there for that matter. But let's see if we've got power from the amplifier. Because if I have signal here, then we know that this board is fine. Cue the dramatic music. We should have sound, but we don't. But we have sound going through the amplifier, and it's making power. So let's go to that protection circuit. I believe the protection circuit is on this side, so now I need to remove the other amplifier because this one's got the power transformer on it. I'm pretty sure the protection circuit was on this side. It's been a while since I worked on this thing. The fellow that owns this has got two of them. And he has all kinds of other audio gear that I've worked on for him over the years. Of course, it's different screws. Somebody put flathead and Phillips in. Duh! The very fact that I did hear audio momentarily and then it cut out, though, kind of told me that there wasn't a problem with the amplifier. I kind of already knew that because, well, I got sound momentarily, but I had sound. So that makes me think it's something beyond the amplifier, and it's going to be probably the speaker protection relay, or it could be the binding post on the back. I guess we'll find out once I get this thing out here and see. We'll just kind of move this out of the way for now. Maybe lay it at the back, do something, put some plastic around it so that nothing shorts out, just so it's out of the way, because I want to get down and smack this stupid relay. Power on. And we have right channel. Oh, left channel just came on. Yeah, you see? I think this problem is here. I think our problem's right there. Let's see here. Now, of course, my MP3 player is between tracks. Okay, right channel's working, left channel's not working. I think it's in here. Give me something to hit with that doesn't have metal prods sticking out the back side of it to short things out here. I think the relay's bad. Yep, I think our problem's right here. Does this relay unplug without pulling the board? It might be a plug-in relay. It's got a cover over it, so I think this might be a plug-in. Let's pull this relay apart and see if the contacts in here are pitted. It could be on the bottom of the board too. We may have to pull that board out, but that really shouldn't be that big a deal because I think it screws in from below. But let's check the relay first, because I bet you the contacts in here are pitted. What the hell is that? It's got magnets on it. What the hell? Look, the relay's got magnets on the side of it. Why do they have magnets on the side of the relay? That doesn't seem to make a lot of sense, does it? But it does have magnets on there. Isn't that weird? Okay. You see there's a little key here. So it only goes in the socket one way because there's a slot between these pins, but not between these ones. So you can't put this relay in backwards because that would be a bad thing if you could. My first guess is that the contacts here are pitted on the left channel, which is this one here, because this is a high power relay. I bet you these contacts are pitted. Let me get in there and look this real close with my good old flashlight. I can remove the contacts, and we can inspect them. Do I have to remove the bottom of the coil? Maybe. So that I can take this apart and give them an inspection. Oh yeah, they're pitted. They're pitted nicely, actually. It should just lift up. It's fighting me every step of the way. One side here does not want to lift. They need to be cleaned up. But this one here, if you look at this one, look at the bottom one here. This one is, yeah, it's bad. It's bad. I don't have a relay. You could probably get one for it. I don't know what it would cost. I'm sure it's not cheap. But we're going to clean these contacts up again and just kind of clean them up. Probably hold it over for a while. I'm just using the end of the deoxit nozzle to kind of wipe the contacts, get some of the oxidation off of it. They aren't so much welded or pitted, it's just they're quite gungy. So we'll just kind of clean them up a bit. Give them a coating of deoxit and put it together and see whether it works. And then I can advise the guy that owns it, hey, you know, might want to look at getting a new relay for it. That might take some research because I got the specs on it here, right? It's just a 12 volt coil, so it's just a regular type 12 volt relay, double pull, double throw, 10 amp. It's just finding one that has the right plug configuration on it. I mean, I'm sure one's available, but you know, when you start getting stuff like this from DigiKey or Mauser, all of a sudden, and I'm sure that they would have it, all of a sudden you've got, you know, $30 shipping for, you know, a part that might be, you know, it might be $10 or $20 for the part. I don't know what a relay like that's worth, but when you start adding another $30 shipping to get it sent to Canada, all of a sudden, you know, you're starting to get into some bigger bucks. And then of course these little magnets have to be stuck on it. I don't know why they're there. They must be there to help it disengage or something. I don't know. I have no idea why they've put magnets on this relay, but they did. We'll put it back together and plug it in and see what happens. You know, as I hold my thumb over the end so that it can't fly away if I miss. I guess it went in that way because it didn't snap in the other way at all. Alright, so that's back together. And let's plug it in and see what it does. It'll work probably now. Okay, relay is back in place. We'll turn on the power. We got left channel, we got right channel. There we go. That was the fault on this one. Okay, I think I can put this thing together and call this one a success. Let the fellow that know that, yeah, you know, if he wants to chase getting a relay, then we can track down a relay and change that out. That's just a plug-in part. I think it was just the relay. It's not the connections on here. Yeah, it was the relay. I think we'll pull I think these screws here hold that relay board in. So let's pop the relay board out. I want to check the connections on the bottom of it. I'm pretty sure these are the screws that hold it in. I guess I'll find out pretty quick when I remove them if it falls out. You can see these amplifiers have a rough life. They're all damaged, bent. Most of them are anyway, because it's just how these things were abused when they were in the field. A lot of these were in movie theaters for the sound system back in the day. The relay board is here, and I don't see any connection problems on here. Which ones are the contacts that are going to the speakers? Looks like that's a speaker contact there, that's a speaker contact over here. And these would be the inputs here from the amplifier. I don't see any connections on here that are bad. They all look good. And I can reflow them anyway just for the hell of it. And since I got the board out, that might be a good idea just to do that, just because the board's out. But it looks like they've been done at some point in the past, and I don't remember whether I did these or not. I guess I could go back and look at the prior video. It was a number of years ago when I worked on this, right? This is not something that I've worked on recently. This was a while back. And what I remember doing on this is I may have cleaned the relay contacts in, but we put this new fan in, right? This circuit test DC brushless fan, because the original fan on this was an AC fan, and it made so much noise it sounds like a jet engine taking off. I mean, it was just ridiculous how loud it was. And I mean, I've got a Crest. Make sure these are tight, which they are. Yeah, those are tight. I have a Crest VS900, which is a little more power than this. This is 750 in bridge mode, and my Crest is 900. But mine has a 2-speed fan. It has a fan that runs at 1 speed. It's an AC fan. It runs at 1 speed, and it does it. There's a relay, and when you two things. If it gets over a certain temperature, it'll kick up to the high speed. But also, if your input level is high enough, it will then kick over to the high speed. And then the low speed fan runs the rest of the time. The thing is, the low speed fan on it was still too loud, and it would you could hear it in the room. So I wanted to keep the fan running, but I wanted just to keep it running very slow, and I ended up changing a resistor. A big wire wound resistor was all they used to drop the speed, so I put a bigger one in, at higher resistance, just to slow it down, so that when it's running in low speed you don't hear it. Because when you're listening at normal levels, you don't need the big honking fan, but it needs to draw air through, because that's the only way it gets ventilation, is air is drawn in through the side over the heat sinks and then expelled from here. So the fan has to run. You can't run one of these amplifiers without a fan, or it's going to overheat. It's going to overheat. It's not, it might overheat. It is going to overheat. Even if you're not running any signal through it, there's going to be enough residual heat produced just from the way that the bias, these transistors are always in a little bit of conduction, and there's always going to be a little bit of heat produced. And if you don't have air flowing over it, it's going to overheat. So the fan has to run. It has to always run. In the case of this one here, I forget why the original fan wasn't working, but or it was always on. It was always on full. It was just too loud. For whatever reason, the owner of this one wanted a quiet fan put in, so this is what went in. This 4-inch computer fan, 12 volts DC, and a little power supply to run it. It's quiet, it works, never going to overheat, and it draws a fair volume of air through, even though it's very quiet. Anyway, that's what we did on this years and years ago. So I'm just going to go over these connections on this plug. And it could be the plug too, but it depends on what pin it or anything. This iron is almost ready to be replaced. It's sad shape. Actually, that one looks kind of cracked, that one right there. And that would be the left channel. I'm just going to just scratch away a bit of the solder mask and just bring some more solder back onto this land. Do the same on this one. We have to get some new solder. Yep, Shintat soldering. High quality solder wire. With a Duracell DL2032 in the middle. This stuff's been pretty good, this solder. I've got no complaints over this stuff. I used to use Kester, but this was pretty reasonable. Started using this stuff a couple of years ago. Actually, probably more than a couple of years ago. I think that's the second or third roll I've gone through. But I doubt these electronics. But the problem is, the days I can get down there are limited, because there's basically just one day a week that I can get off, that I can go. Well, Friday's when I have my Friday off. Like today, I can go down there today and buy some if I really felt. No, I can't. It's 4 o'clock. They're open to 5:30, but I don't feel like going. Don't feel like going to downtown to pick up some solder today. And tomorrow they're closed, so I'll have to make do with what I've got. I guess if it gets down to the point where I need some solder for a project and I don't have any, I'll have to put it on hold. Mount this relay board back in, and then we'll check it out again, make sure everything's working properly. Alright, the relay board's back in place. Power on. Left channel. Right channel. That part's working. One thing I didn't notice though is that when I was checking this, is that the fan is not turning. The fan I replaced a few years ago is not running. So we need to figure out why it's not running and make it turn, because one of these units without a fan is not going to last very long. It's going to shut down or do something. The fan's got its own 12-volt power supply that powers it up. So make sure that it's got power. Okay, there's a terminal here. It's got power going into this adapter that I just put in here and stuck it in the back. Nothing fancy, it's just an AC adapter that's been screwed down. But 120 volts goes in on this little thin wire here. 12 volts comes out and goes into the fan itself. So let's just pull up the 12 volt wires and see whether we've got 12 volts coming out of the adapter that's in here. Because, you know, I guess it's even easier just to cut the wires, put 12 volts to the fan and see if it turns. That'll tell me whether it's the fan itself or whether it's the power supply. And so let's just nip the wires here, turn on the 12-volt adapter, crank it up to 12 volts, close enough, and we'll just apply 12 volts here and see whether the fan turns. And if it does, then we know that I got to find another 12-volt adapter. I had a little switch mode that I put in that I just happen to have kicking around. It doesn't have to be that. It could be anything. Anything else, supply it with 12 volts of juice. There's the positive, and there's the negative, and I feel the fan coming on. Therefore, our power supply is FUBAR. We can, of course, check that by just stripping the wires back a bit here and put the meter on it and turn on the power, because it should come on immediately with 12 volts. So 12 volts DC on the meter, or I should say DC volts on the meter, and when I connect my meter up here to 12 volts or to the power supply and turn on the power, I should have 12 volts. Well, I got 5. I think that power supply's got a problem. This adapter should do the job. 1.67 amps. Yeah, I don't think the fan's going to draw that. And it's not much, a little bit bigger. The thing is size, right? But I won't have the prongs that I have to worry about. I can just wire this right into here. Cut this cord back a bit and wire it right in. We'll do that. First things first, connect the AC. We can just take that one off there, and we'll tie this lead down under that moret. That one's on, and this one was just added to this terminal here. So we'll just do the same. Every time I use it, it's getting worse. It will solder. It will. It will work. Just like that. I know someone's probably going to say I should put heat shrink tubing on it, but I don't have heat shrink tubing that's big enough to fit around that. So black tape will have to suffice to insulate this terminal, which is not a problem. It will insulate it, no problem. You see? No problem at all. Plug that terminal back where it came from. I think it was on that one. And plug the power supply in. Stuff it down inside here somewhere where it's out of the way. The marked side with the white stripe should be positive. I'm not even going to bother to test it because I know it's going to be positive. Better be positive. Twist the wires, solder them, and then throw some heat shrink tubing on. And that should get this one back up and running and get it ready to go back home. stuff the wires out of the way. Power supply's out of the way as well. And we'll hit the power switch. Does the fan come on? Yep. Yeah, it's blowing lots of air in here. Actually, it's bringing air in. Yeah, the fan's working fine. Can you guys see it spinning? Maybe not, but it is spinning. Here, I'll turn it back on. There it goes. And off. It has turned into a very warm day here today. Very warm. I'm going to put this back together and call it a day. And then get out of the hot garage. Even though I do have an AC unit running, you can probably hear it. Well, that keeps the area where I'm actually standing in the draft from the cool air, but if I step into any other part of the shop, it is bloody hot. It's going to be probably one of the hottest weekends of the summer. This summer it's going to get really warm. It's 24 Celsius in here right now, and that's with the AC running right where I'm working. It would probably be if I didn't have the AC running, it's like 4:30 in the afternoon now. It would be like probably 30 plus in here without the AC. It gets real warm in here. That's why I've got the AC. That's why that AC unit I got last year was so welcomed, because even though it's one of these ventless ones, well, it has a single pipe, right? Single output, so it actually uses room air as the exhaust air. But it's still, relatively efficient, probably giving me 8,000 BTUs of actual cooling. But the heat in here is just so hot because this particular part, like the insulation's all in the house. They put insulation on the exterior wall when they built the place, but they didn't put insulation in the attic directly above me. And I can just feel the heat blasting down from the ceiling. It just gets very, very hot over the garage here. That's because when this was built, it was built as a garage to store a car and not so much a workshop. I have a couple of Betamax units en route to work on, coming from one of my clients in Toronto. I've done a number of his beta machines for him, and he trusts me because I've been getting his beta machines working, whereas the guys that he was dealing with before, well, they weren't getting them working. So he ships them all the way out here to have me take a look at them. And he just informed me last week that he was shipping me 2 more. Like one of them's an BGW750, the one in the drawer, and I forget what the other one was. It might have been 900. Anyway, that's what's coming up maybe next week when they get here. If they get here. They will arrive when I'm at work, and it all depends. Hopefully the guy that delivers it will read the sign. It's being delivered to my address just because the fellow knows where I live. I normally have stuff sent to my P.O. box, but the fellow knows where I am, so he sends it to my address. And well, sometimes the delivery guys, I got a sign that says don't deliver anything to the front door. Everything goes around to the back, or to the side, or onto the back, preferably, because it's secure. But some of these jackasses that deliver for companies, they don't seem to know how to read. Even though the sign says, please don't leave anything at the front door, because the thieves work around here and they see a couple big boxes sitting at the door. They don't know it's something that's broken. They think it might be something that's valuable, and they take it. That happened to me a few years ago. Lost a DTC75 ES. I know some of you might be quick to jump, say it's my fault, but it's not my fault. The sign said don't leave it at the front door, and the delivery guy left it at the front door, and well, somebody else thought it looked nice, and they walked away with it. It was broken, so I hope they enjoyed getting a broken DAT machine that was useless to them, but still would have been nice to save it. There we go. Right channel, left channel, stereo. For those of you guys wanting to hear the Music Bakery stuff, there it is. I haven't put the AI stuff on here yet. I don't think I will. I don't know, this may be a problem. Running that fan at 12 volts, it's making noise. That other adapter that was only putting out 5 volts, incidentally, was a 9 volt adapter that I had put in there. And it had dropped to 5 volts. And I think probably I went with the 9 volt adapter so the fan wasn't being driven quite as hard as it is now, because, well, not as loud as the original fan was. It still is, it's something you can hear. That might be too much. Nothing like the original fan that was in here that sounded like a jet engine, but that's relatively loud. I may have to throw a resistor in series with that power supply just to drop the voltage down a little bit, just so that the fan's not blowing quite as hard, because yeah, that's a little bit on the loud side, I think. I mean, if it's installed in a cabinet, it's probably not so bad. But you can certainly hear it, that's for sure, with everything shut off. I don't know how that comes across on camera. It's probably sounding louder on camera than it is. But I mean, you can hear that fan. It's making noise. What I'm going to do, you see what I mean? They're broken. What I'm going to do is I'm going to leave it at that, and see if it's too loud for him. If he says it's too loud, then I'll have to find a power supply that's a little bit less power. Since I was running it at 9 volts, but that 9 volt adapter has failed, and it's now only putting out a little over 5 volts. So I don't have another, I'm looking through my adapters here, I don't have another adapter that's 9 volts or even a 7.5 volt. All I've got is 5 and 12 volt adapters. So maybe a resistor in series will slow it down a bit. It doesn't need to be a big resistor because the fan doesn't draw a lot of power, you know, but I may have to do that. I'm going to talk to the guy that owns it and let him decide whether that's too loud, and you know, I don't know whether he's got installed in a cabinet, or if it's installed in a cabinet, for example, that's going to buffer out the sound anyway. So, but I'm going to leave it at that. This one's working, and we'll say, because I want to get inside, because it's just I'm starting to roast out here. Turn off the AC. Now it shuts down. Now it'll get quiet in here. There, see? That's how I like it, nice and quiet. Anyway, that's it for this one. We'll catch you in the next one. Bye.